Welcome back then to lesson 7 of our patterns of periodic table topic. Today we are looking at the reactivity series, which is a continuation of last lesson, and then looking at displacement reactions. A couple of lessons ago we looked at displacement reactions with the halogens, and today we are looking at the displacement reactions using metals. So last lesson we created a reactivity series by reacting metals with either water or with acid or with steam in order to see how they would react in comparison with another one. So magnesium, for example, reacted with acid, creating a loud hydrogen pop, squeaky pop, and creating lots and lots of bubbles of hydrogen gas. Zinc, on the other hand, was slightly less reactive. It still made hydrogen, it still made a pop, it wasn't as loud, and it didn't make quite as many hydrogen gas bubbles. So we knew that zinc was slightly less reactive than magnesium, and so on and so forth. So how does this work, and how can we use the reactivity series to predict chemical reactions? Well, let's have a go. So here you can see I have got iron, which is a metal. You can see that on the reactivity series, and you can see copper. Copper is also on the reactivity series. So here are my two metals. There is, however, only one oxygen. Now, obviously that's not realistic, but just go with the flow here. So these two metals both are reactive, but which one of them is going to be more reactive and which one is going to react with that oxygen? Is it going to be the iron or is it going to be the copper? Well, hopefully already you've looked at the reactivity series and you've noticed that iron is higher up the reactivity series than copper, and therefore you've realised that iron is more reactive than copper. And so in this example, the iron and the oxygen would bond together as a compound and copper would be left on its own. It wouldn't have the opportunity. Iron's already got there first. Now you'll notice that it's no longer iron and oxygen. What would it be? It would be iron oxide, the compound. And we talked last lesson about them being colourful. Often iron oxide is a rusty colour. What about this one here then? So I've got calcium and potassium, they are both metals. And I've got the chlorine, which is the non-metal. Which one of those the metals is going to react with the chlorine first? Well, if we looked at our reactivity series, you can see potassium is more reactive than calcium, and so it would react with the chlorine. The calcium would not have the opportunity. What's the name of that compound? Well, it'd be potassium chloride. What about then in this situation? Now, iron has already bonded with the oxygen. I've already got iron oxide, but now I'm introducing a second, more reactive metal. So zinc, if you look at the reactivity series, is more reactive than iron. In fact, it's so much more reactive than iron that it will displace the iron. Now we've looked at that word before, okay? It will cause iron to move from one place to another. In this example, that other place is all on its own. So zinc has displaced the iron atom. It's swapped places with it, hasn't it? So I end up with a new chemical. I end up with zinc oxide and iron all on its own. Now this is really useful if I want that iron on its own. So displacement reactions can be extremely useful. Now I want you to notice that there is nothing new on this side of the equation. I started off with one zinc, one oxygen and one iron, and I still have one zinc, one oxygen and one iron. All I've done is I've rearranged them. Chemical reactions, conservation of mass, conservation of atoms, guys. You don't just suddenly introduce another oxygen. Same before and after, they've just rearranged themselves. Okay, so here's it looking a bit closer. We've looked at this a couple of lessons ago with the halogens. All that's happened is that they've swapped around, the two metals are swapped around to get a new product. What if we flipped this equation round? So zinc, the more reactive metal, is already part of the compound. It's already got the oxygen. And then we introduce iron, a slightly less reactive metal. What's going to happen in this reaction? Well, absolutely nothing. iron is not able to displace the more reactive zinc. So there is no reaction. Now we could just leave our reaction unfinished, or if you wanted, you could simply repeat your reactants from the beginning. So zinc oxide plus iron makes zinc oxide plus iron, because iron is not reactive enough to displace the more reactive zinc. The general rule then for displacement reactions, and this works for the halogens as well, is if the more reactive metal is on its own at the start, you're going to have a reaction. Or if the less reactive metal is on its own at the start, you don't get a reaction because it cannot displace the more reactive metal. So I want you to pause the video and I want you to have a go at these 4-word equations. I don't want you to worry about them getting them wrong, because if you make mistakes, I want you to understand why you've made those mistakes. So pause the video and have a go yourselves. Okay, so the first one then, I'm looking at iron oxide plus magnesium. I'm looking at the one that's on its own, magnesium, and it is the more reactive one, and so I will have a chemical reaction. So I just swap the metals round. So I end up with magnesium oxide plus iron. Now some people will have written iron plus magnesium oxide, that's absolutely fine. Some people, however, will have simply written magnesium oxide and you'll have forgotten about the iron. Don't, it's still part of the word equation, it's still part of the reaction. So look at the second one then, copper chloride plus iron. Okay, well I'm looking at the one on its own, iron, and iron is more reactive than the copper. So I'm going to have a reaction and end up with iron chloride plus copper. The next one then, I've got sodium sulfate plus silver. So sodium sulfate plus silver. Silver on its own there is not very reactive, and sodium, which is part of the compound, is much more reactive, right? So the silver is the less reactive one. So the less reactive metal is on its own, so there's going to be no reaction. And so I simply leave it, or I could put no reaction, or I could just rewrite the same thing. So the final one, I've got sodium sulfate again, but this time I'm reacting it with potassium. Potassium is actually more reactive than sodium, so the more reactive metal is on its own at the start, so I'm going to get a reaction potassium sulfate plus sodium. Now I have noticed here I've used equal sign instead of the arrow. That is not good. Slap my hand, Mrs. Newsom. Sorry, so that should be, the equal sign should be arrows. So you will need to know what the practical for this actually looks like. How would you use displacement reactions to create an order of reactivity? So this is similar to what we do with the halogens. It's slightly different. We're going to use spotting tiles. We don't need a huge chemical reaction. We could do it in conical flasks, but it's just a waste of materials. I just need to see whether there's a chemical reaction. So I'm looking for a colour change or any kind of bubbling going on. You can see at the bottom there, I've got my liquids, my compounds, magnesium sulfate, copper sulfate, iron sulfate and zinc sulfate. It doesn't have to be a sulfate, it's just got to be part of the compound. And then I've got all my magnesium ribbons here. There's my copper pieces, my iron powder and my zinc pieces. So those are the elements that I'm going to be reacting with the compounds. And what I'm looking for, my rules here then, is if there is a reaction, the more reactive one was on its own at the start, and if there's no reaction, the less reactive one was on its own at the start. Okay, so I've drawn out this table. If you want to play along, by all means copy that out very quickly if you want to. If not, just watch as we go through. Now I appreciate this is not the easiest thing to see on a video, so I have included the link at the end of the video. If you want to watch the YouTube clip, it will make a little bit easier to see. So first of all then, zoomed in on my pieces. Here I've got magnesium and I'm reacting it with magnesium sulfate. Well, hopefully magnesium plus magnesium sulfate, guys, you should realise if I've got magnesium, nothing's going to happen. They're both the same. Okay, then I'm going to have copper and magnesium sulfate. So you can play along. Do you think that's going to work? Copper displacing magnesium? I don't think so. And there's no reaction there. Now this is the bit you can't see. It's really difficult to see whether there's bubbles or not. You'll just have to trust me. Here then, iron plus magnesium sulfate. Is iron going to be reactive enough to displace the magnesium? No. And what about zinc? Zinc plus magnesium sulfate. Is zinc more reactive than magnesium? Is it going to be able to displace it? No, it's not. Okay, first line done. Okay, then we move on to our second. You can see that lovely blue copper sulfate then. So here, magnesium plus copper sulfate. So is magnesium reactive enough to displace the copper? Well, I can kind of see there some bubbles. Yes, it is. This one here, I've got copper plus copper sulfate. Well, the same metal, so that's not going to do anything. Next one here, iron plus copper sulfate. If you look carefully, you can see a slight colour change. You can see the blue of the liquid is actually slightly paler, and you would see bubbling there. There is a reaction. And then finally, zinc plus copper sulfate. Again, there's a slight change in the colour of the blue. There would be some bubbles. Yes, there's a reaction. Now you can imagine this is why we do this as a practical rather than as a teacher demo or watching a video. Okay, so the next lot then, we've got magnesium plus iron sulfate. There are some bubbles there, lovely. This one, copper plus iron sulfate. I can't see anything there. Iron plus iron sulfate, well, they're the same, so that's not going to work. And zinc plus iron sulfate, it's really hard to tell, but there should be a couple of bubbles there. There is a reaction. And finally then, this one here, magnesium plus zinc sulfate. There is some bubbling. You can kind of see some specks in there. This one here, copper plus zinc sulfate. Can't see anything happening there. Iron plus zinc sulfate. I can't see anything happening there. And zinc plus zinc sulfate, well, yeah, well, it's the same metal, isn't it? So nothing's going to happen there either. Okay, so now we've got a set of results. What can we do with it? Okay, so here are our results, and more often than not, we're going to be asked to use these results in order to put these metals in order for reactivity. If you want to have a go at that yourself, pause the video. If you don't want to do that, just keep going. So the most common mistake I see is somebody looking at these results going, oh, magnesium sulfate, loads of crosses, no reactions, that must be the most unreactive. And then zinc sulfate's got 3 crosses, iron sulfate's got 2 crosses, and copper sulfate's only got 1 cross. Right, well, that must be the order of reactivity. Well, first of all, it's asking for the metal. So you might say, oh, okay, let's just get rid of the sulfates. But just look at those results. Copper is at the top of this reactivity series. Copper is more reactive than magnesium at the bottom. Does that sound right? Doesn't, does it? So this is where you use your common sense and you use your prior knowledge. If you're answering a question, check yourself. You know that magnesium is more reactive than copper. So this answer must be incorrect. So what I would suggest you do is you remember that you are looking just at the metals. You're not looking at the compounds, you're looking at the metals. These were the ones that were on their own in the beginning. And remember, we keep saying if there was a reaction, the more reactive one was on its own at the start. No reaction, the less reactive one was on its own at the start. So we need to know which metal was on its own. If we look at this and we look across the table rather than down the table, we can see that magnesium has got 3 reactions, more than any other, so it is the most reactive. We can see that zinc has got 2 reactions, it's displaced 2 things, so it's the second most reactive. Iron has managed to displace 1 thing, so it is next. And copper, look at copper, it's not managed to displace anything, has it? And therefore it is the least reactive. Now look at that as results. Magnesium is more reactive than copper. Well, I'm hoping you'll be pretty confident with that statement. Zinc and iron, you might be a little bit less sure, but magnesium and copper, you're pretty convinced you're right there. If you've managed to memorize the reactivity series, of course you would know that already. So it's using what you know to inform your answer. Here's another example. So this is one I've just pulled straight out the revision guide, and you can see there's a lot more writing there. It looks a lot more complex. So the first thing I would do before I try to put these in order of reactivity is wherever there's no reaction, I'm going to put a cross, and wherever there is a reaction, I'm going to put a tick. So no reaction, no reaction, no reaction, no reaction. Magnesium sulfate and zinc are formed, so that's something new's been made. I've got a reaction, no reaction. Okay. Now I can see much more clearly what I've got in front of me. I'm going to make sure I'm looking at the correct metals. Am I looking at the ones on their own? Am I looking at the compounds? I'm looking at the ones on their own. Okay, right. Which one's got the most ticks? Magnesium, then zinc, then copper. Does that make sense? Magnesium, zinc, copper. Yes, it does. It follows along with what we know. Okay, so in front of you then there is the clip for YouTube if you want to watch that displacement reaction practical in a bit more detail. It's not terribly clear, but it should be easier to see than my clips. And then if you want to try the Educate quiz, please. Again, it's not about getting the correct answers, it's about learning from your mistakes. Doesn't matter if you get 50%, if you know why you got 50%, learn from your mistakes. That should be live on the 13th of July 2020, and I will see you next week. Bye.